Okay, Assalamualaikum and hi everyone. Alright, today I would like to discuss a tutorial question that is referred to the buffer solution and also its calculation. Right, so the first question here, define buffer solution. So this is the answer. Okay, buffer solution is a solution which has the ability to maintain its pH when a small amount of strong acid or strong base is added to the solution. So for definition question, you will get 1 mark. Question number 2, calculate the pH of solution containing 0.2 molar ethanoic acid and 0.3 molar sodium ethanoate. Given to you the K value. What should we do? So this is referred to the acidic buffer solution. So therefore, first of all, you have to write the Henderson-Hasselbalch equation to calculate the value of pH. Alright, so second step, substitute all the values. So P here is 10 for negative log Ka. Right, so conjugate base here is referred to CH3COO minus ion that is produced mainly by the dissociation of the salt. So therefore, the concentration of the conjugate base is 0.3. Okay, whereas for the concentration of the weak acid, 0.2. So the answer here, suppose you get 4.92. Okay, alright. So how many mark that you will get from this calculation? So the first mark is given to you when you write the equation, 1 mark. And then substitution, 1 mark. So it's better if you define what is the conjugate base. Just label. Okay. And also what is the weak acid to be safe. So now we move to question number 2B. So this is 2A. Now we move to 2B. Explain the change in pH of the solution when a small amount of strong acid is added. And second, a small amount of strong base is added. Okay, so here is the sample answer, right? So the first point here, when a small amount of strong acid is added to the buffer solution, so the H plus ion from the strong acid react with conjugate base, okay, to form weak acid. Okay, so this is 1 mark. And then you write the equation involved, another 1 mark. Alright, next, so the concentration of conjugate base will decrease, whereas concentration of the weak acid will increase, 1 mark. And then lastly, pH of buffer solution is not much affected. Just write general like this. Okay, 1 mark. Okay, for number 2, when a small amount of strong base is added to the buffer solution, okay, the OH from the strong base react with weak acid to form conjugate base. So this is 1 mark. Right, next, write the equation involved. Okay, and then the result here. So the concentration of weak acid decrease, concentration of conjugate base increase. So the pH of the buffer solution is not much affected. This is 1 mark, concentration 1 mark. Alright, so next question is question number 3. Calculate the ratio of concentration of ammonia to ammonium chloride needed to form a buffer with pH of 8.3, given to you the Kb values, okay, of ammonia. So what should we do? So first of all, since the question give here is in pH, and this is referred to the basic buffer, so because contain weak base and its salt. Okay, so therefore, first of all, you have to find out the value of pOH. Okay, use this formula to calculate the value of pOH. Alright, so second step, use the Henderson-Hasselbalch equation to calculate the ratio. So what is the conjugate acid? The conjugate acid here is referred to the ammonium ion. that is come from the salt. Okay, and the weak base here is. Alright, so the second step, you can substitute all the values, pOH. Okay, and then values of pKb. P here is stand for negative log. So Kb 1.8. Okay, conjugate acid concentration of NH4 plus over concentration of NH3. Okay, for the next step, so you have to solve the value of negative log Kb. Okay, find out the values. So from here, we will get here 5.7, 4.7447. Alright, so next, move 4.7447 from right side to the left side. So you will get like this. Okay, next, move log from the right side to the left side, and it will become anti-log. Anti-log, which means 10 power of 5.7 minus 4.7447. Okay, so equals to concentration of conjugate acid over concentration of weak base. Alright, the next step, when refer back to the question asks the ratio of ammonia, okay, to the ammonium chloride. So we have to rearrange back this. So rearrange back. So therefore, ratio of ammonia to ammonium chloride. So we will get here. Okay, so and finally we will get 1 to 9. Okay, how many marks that you get from this calculation? Alright, so the first mark, you calculate the value of pOH, first equation, and then value of pOH, 1 mark. Henderson-Hasselbalch equation, 1 mark. Substitution is another 1 more mark. And lastly, final answer, 1 mark. Alright, and the last question for this tutorial is question number 4. So calculate the pH of 0.3 molar NH3 and 0.36 molar NH4Cl buffer system. What would be the pH after the addition of 20 ml 0.05 molar NaOH to 80 ml of the buffer solution? Alright, so first question here, calculate the pH of the buffer system. Mean that, okay, the buffer before the addition of the strong base. We can directly calculate. So for this one, since the buffer system here, this is referred to the weak base and this is its salt. Okay, so the buffer system here is referred to the basic buffer. So therefore, we have to use the Henderson-Hasselbalch equation to calculate the pOH. And then substitute the values of pKb, negative log 1.8. Okay, so for the conjugate acid here is come from the salt. So when you calculate, suppose you get the answer here is 4.82. Right, so second step, calculate the pH of the buffer solution by using the formula of pH, pOH. Okay, and the value of pH for the buffer solution before the addition of strong base is 9.18. Okay, so this is for the first calculation. Okay, for the second calculation, what would be the pH after? Okay, pH after the addition. First of all, what should we do? Okay, so we have to solve this problem by using ice table, right? Write the equation first. So equation here is referred to the added OH minus ion from the strong base. It will react with the conjugate acid. Okay, so we'll get like this. Right, since this react as conjugate acid, so acid will donate a proton to base. So it become NH3. Neutral without any charge. Okay, and one more product is referred to H2O, liquid. Okay, right. Okay, next, draw the ice table. Okay, so now we want to calculate the initial mole for conjugate acid, the added OH minus ion, and also the weak base. Refer back to the question. So in the question here, it's already given the buffer solution, volume of buffer solution that is 80 ml, and then volume of sodium hydroxide 20, molarity of sodium hydroxide is 0.05, and we have also the concentration of weak base and also its conjugate 0.36. Alright, so now to calculate the mole is referred to the molarity times with the volume, and volume should be in liter. Okay, conjugate acid is come from the salt, alright, that is referred for 0.36, so substitute. Time volume of the buffer solution. So you get here 0.0288 mole. Okay, as for the hydroxide ion, okay, so the concentration here is 0.05 times volume. Should be in liter. Okay, you get here 1 times 10 power of negative 3 mole. For the weak base, concentration is 0.3 times volume of the buffer solution. So you get here 0.024. Okay, as for the H2O is in liquid, not consider, just write dash. Okay, for the change in concentration for the reactant, so the reactant will decrease. So usually we will write negative X. Okay, hydroxide also decrease. Negative X, product increase. H2O dash. Alright, so now refer back to the initial mole of both reactant. So we can see that okay, OH minus ion has smaller number of mole than conjugate acid. So therefore, this is the limiting reactant. So as we already know, limiting reactant, the function here is limit the amount of product form, and it will completely consume. Okay. Alright, so meaning that mole at equilibrium for OH minus ion is 0. So therefore, from here we will know the value of X. That is referred to 1 times 10 power negative 3. Okay, as for the product, weak base, also the same. Right, next, mole at equilibrium. Right, so 0.0288 minus 1 times 10 power negative 3. So you will get 0.0278. Okay, and for the weak base, 0.024 plus 1 times 10 power negative 3, then you'll get here 0.025. Okay, next is concentration at equilibrium. So therefore, concentration is referred to the number of mole at equilibrium over volume total. So what is the volume total? Volume total is referred to the volume of buffer plus volume of NaOH added. Volume of buffer is 80 ml. Volume of NaOH added is 20 ml. Total up, you will get 100 ml. Convert into liter, you will get 0.1 liter. Concentration at equilibrium for NH4 plus 0.0278 over 0.1. So we get 0.278 molar. Okay, as for the hydroxide ion is 0 because completely consumed. So concentration for the weak base at equilibrium 0.025 divided by 0.1, you get here 0.25 molar. Okay. Right, so for the next step, since we already calculate the concentration of the conjugate acid and also weak base, so therefore we can calculate the pOH value by using Henderson-Hasselbalch equation. Alright, so now substitute the value. Okay, so for the concentration for the conjugate acid, so we have to refer to the concentration at equilibrium. So substitute. Okay, so when you calculate, suppose you get the answer for POH here is 4.79. So since the question asked here is about the pH, so alright, so the next step, calculate the pH by using this formula. Okay, and the value of pH is 9.21. So tutorial 7.2 is refer to the acid-base titration. Right, so the first question asks you to define what is titration. Okay, and then what is endpoint, equivalent point, and what is indicator. So I think all this definition you can find out in your lecture note. So I would like to discuss the second question, which is more important here. Right, so we take a look at second question. 25 ml, 0.1 molar HCl is titrated with 0.1 molar NaOH. Okay. The variation of pH values of the solution in conical flask are obtained as follows. So this is referred to the volume of NaOH added, which means NaOH is placed in the burette. This is the value of pH. So inside of the conical flask placed with HCl. Alright, so sketch the titration curve and give a suitable indicators for the above fraction. So titration curve and suitable indicators. Alright, so what should we do? So first of all, we have to analyze. So this fraction is between HCl, which is strong acid. Okay, react with base and AOH, that is referred to the strong base. And it will form salt and ACl and also water. Okay, so since the titration here is involved strong acid and strong base, so the salt form here is a neutral salt. So because of that, the pH range, okay, pH range for strong acid and strong base is between 3 to 11. Ma, Va over Mb, Vb, so equals to A over B. A here is referred to HCl. B is referred to the NaOH. Okay, so this is volume of the HCl. And this is the molarity of the HCl. And this is the molarity for the base. Okay, so therefore we want to find out the volume of NaOH at equivalent point. Alright, so next we substitute all the values. Okay, A and B here is referred to the coefficient. So coefficient for acid is 1. Coefficient of base also 1. So 1 over 1. Okay, so from here we will find out the volume of base that is referred to NaOH at equilibrium is 25 ml. Okay, from this table, so we notice that at 25 ml, the pH here is 7. Alright, so now start sketch the graph. Start with the x and y axis. Okay, so remember to label. Y-axis is pH, x-axis refer to the volume of NaOH added and the unit ml. Alright, so next, you have to label at equivalent point, that is 25, and then 7, pH 7. Must also label the pH range 3 and also 11. Okay. Right, so for easier for you to draw, it's better if we write the sharp line here for the pH range. Sharp line. Okay. Alright, and then you have to label here 1. So start from 1, draw the curve, increase. Okay. And then ended at 12, 12.22. So right here is about here 12.22. And then don't forget to draw the dotted line here and label. Okay, this is equivalent point. Alright, so how many marks that you will get from this calculation? Okay, from this question, alright, so first mark, maybe you can write the equation, 1 mark, and then the formula and volume as is 1 mark. Okay, and then label. What should you label? So label the pH 7, which refer to the neutral salt and also equivalent point. Okay, 1 mark. Okay, and then one more thing is volume at equivalent point. And lastly is the curve. Curve is another 1 mark. Okay, and then one more question, suitable indicator. Right, so the suitable because it's strong acid, strong base. And then it's mentioned here suitable indicators. So more than one possible indicator. So we can use phenolphthalein. Okay, one more is bromothiamyl blue. And you can also use chlorophenol blue. Okay, phenolphthalein, the pH range is 8.3 to 10. Okay, bromothiamyl blue is 6. Chlorophenol blue is 6. So this one is another 1 more mark. Okay. Alright, so I think that's all for today. Thank you.